Test. Okay. Seems it's live now. So not that much new on not much new on the actual FPGA this time. Well, at least not that's demonstrated on video. Mostly had been working on a new PCOF loader and yeah, made a little bit of progress there, and also had modified the CPU core to be dual core and stuff. So it now is using a fair bit more of the resources, but this is 2 cores as opposed to a single core. So increased resource usage is not unexpected. Currently there's not yet any cache consistency mechanism, so that does hinder things a little bit. Traditional multi-threading won't, well, as we expect it to work on PCs, won't really work correctly in this case, because you modify stuff in one thread, it won't necessarily be reflected on the other threads, absent the use of explicit synchronization. So yeah, but it is like at least possible, and for all I know, I might add cache consistency eventually. Actual mechanism for doing so kind of goes through VRAM. Yeah, so it's basically using VRAM as a scratch pad for inter-core communication for now, but that might change later. Yeah, the reason for that would be like reads and writes into MMIO space are implicitly always synchronized. So reading and writing from video memory is also implicitly synchronized, albeit it is slower than accessing the main RAM. But, yeah. In other news, had been working on a port of another game and stuff. In particular, Rise of the Triad. So, yeah. I need to. Yeah. So, I haven't yet ported it to BJX2, but I did get it more or less working on Windows. So, it seems to do its little title screen, and it plays demos. So, basically for context, yeah, Rise of the Triad is another game from around the same time frame as Doom, except it's built on a modified version of the Wolfenstein 3D engine. But it's, you know, instead of a single layer of blocks, it's 3 layers of blocks. So whole game is built around essentially 3 layers of blocks. Well, and also there's a floor and a ceiling, which is something that which didn't exist in Wolfenstein. So, but yeah, getting it thus far was kind of a pain because, well, the original code wasn't really isolated from DOS specifics really much at all. So, the first, like, few days of the porting effort thus far had been mostly, like, ripping out and replacing stuff specific to MS-DOS. Which was, you know, spread over a significant amount of the engine. And also funkiness, being that, like, you know, while other games like Doom and Quake and Hexen and similar were content to use essentially the VGA Mode 13 interface, which, you know, gave a 64K byte linear frame buffer. Well, ROTT was content to do something different, so it's not actually using a linear frame buffer. It was actually using essentially a planar mode. So it would, you know, jerk off with some registers and stuff for whichever of 4 possibilities each byte in video memory where it would map to in the frame buffer. So, or where it would map to in video memory. So that was kind of annoying. I'd considered various possible workarounds for that, like rewriting it into a linear frame buffer, or one possibility which I ended up not going with was the possibility of basically copying over the contents or the subset contents of VRAM every time the little register was changed. However, that would have come with a pretty high performance penalty, even if it would have possibly required the least amount of code modification. The option I ended up going with was kind of an intermediate of more or less wrapping all the writes to video memory through function calls, which is also kind of a terrible way to redraw the screen, but sort of works in this case. So I can look around and, you know, stuff. I could have been using cheat codes, except for whatever reason I don't have those working yet. Oh yeah. The logic for drawing all the spans and so on, I just sort of had to hack together again because that part was actually missing from the code. But, oh yeah. The little blinking dark spot is a different kind of different kind of span. Basically, it's a trans span, or I'm guessing translucent. I just had to figure out how that one worked by looking at this at the x86 assembler code and then rewriting it in C, but yeah. So there's still some minor rendering issues, probably masked somewhere. But yeah. Yeah, I suspect those little lines on the walls are probably a math bug. Probably with one of the divisions or something. Yeah. Oh yeah. Yeah. That works. As noted, or as can be noted, this is a 64-bit port. Some of these stuffs like the switches and other stuff like that had in the original version of the game worked by essentially sticking addresses into an integer value, which, as noted, won't really work in 64 bits. So, had done the sort of so had done the sort of workaround of something. Oh yeah, of like basically swizzling all those pointers to integer values. So got distracted. Yeah. Yeah, kind of needed to, yeah, at least try to make this stuff 64-bit clean. So that, like, you know, it'll work on BJX2. Keyboard is, I suspect, not fully working, but yeah, that was also some code I had to hack together a fair bit. But yeah, a lot of stuff seems to be working here. Some stuff not so much. But, partly it's a case of, wandering around and seeing when it crashes, and then, debugging it. But yeah, it was initially at least also pretty fairly prone to more or less freezing up and stuff, because there's a lot of cases in the code where they were going into what were effectively infinite loops, but then expecting interrupts to resolve the issue. So, but that doesn't really work in this case. Actually, I was pretty sure these worlds were 3 blocks tall, but this block appears to be 4. Might have to go and look at the code a little bit more to try to figure that one out. But yeah, in any case, it can be noted, yeah, it is essentially a stack, or effectively like several Wolfenstein maps stacked together. But, yeah. what can I note about this game besides its, you know, possibly suspect code quality? Well, I guess in some sense, it can be noted that, yeah, is kind of like a precursor to, kind of like a precursor to like Minecraft in the sense that, like, you know, both of them are using cube-based worlds. Just ROTT differs slightly in terms of its structure. Yeah, because yeah, Minecraft is full 3D, whereas this is, you know, still kind of 2.5D, and has several layers. Isn't quite the same as, like, you know, the full like 256 layers. But yeah. Yep. Other related game I could try porting as well from the same company that made this one was a game known as Duke Nukem, or Duke Nukem 3D, which apparently they also released the source code for. But the source code for like that game has actually quite a bit more hair than the source code for this one. It's kind of why I went for this one first. myself up there, but the actual X thingy doesn't work yet. I have to put in some logic for that. Yeah, yeah, there's a delay function, but as can be noted, this is still a stub, and these ones I didn't really spot the difference between the different post functions, so I just sort of reused it. The columns had well, slight differences, so I did do different versions of some of the columns. Wall or floor drawing logic can be noted that it's using an 8-bit fixed point format rather than using an 8-bit fixed point format rather than 16-bit. So that's one difference, and also the floor texture is apparently 128 pixels rather than 64. Oh yeah. Oh, yeah, and here's an example of the infamous wrapper function. So it just sort of replaces what would have been directly storing to a pointer with calling a wrapper function, which some of these will probably have to be replaced for the BJX2 port. Yeah, because for the span and column drawing functions, in any case, well, these need to be moderately fast, so can't really justifiably be calling a function pointer every time, or calling a function every time it's necessary to store a pixel. But for the time being, for this Windows port, this is how it works. Most of the change to actually go over to this particular mode was going and mostly replacing all the pointers with essentially the unsigned type. I could have used int otherwise, but or I could have come up with like a type def to wrap, like basically be all like, yeah, this is a pointer to screen memory, but went with this because it's, well, it's lazy enough, and it's technically different than int, so it's distinctive, but not quite as much of an obvious, yeah, this is a pointer into screen memory type thing. In this case, it's not actually holding an actual memory address, but rather it's to a sort of fake address that's local to the screen memory. And a lot of this stuff was, just sort of throwing in placeholder logic to, replace throwing in placeholder logic to replace the stuff that would have been otherwise done in assembler. So, more stubs. So, it does its timing via a counter. This counter was, I guess in the original DOS version, intended to be updated via an interrupt handler, but that doesn't really work on Windows, and not really an ideal solution for BJX2 either. Yeah. So, most of the actual frame ending or similar is handled via this flip page function, which I guess is actually like more or less how ROTT normally did the screen redrawing, was via triple buffering. So their fancy planar mode, and their fancy planar mode, there'd be 3 different page pointers, and whenever it flipped the page, you advance to the next one. But in this case, I didn't really bother with recreating that particular piece of the logic, but could do that if I wanted. But since in this case it's being drawn off screen, it doesn't really actually matter. And yeah, other cases like BGA memset basically does the equivalent of a memset, but for the little faked VGA thingy. Some of this is code I copy pasted from my Doom port, so if any of that looks familiar. Yeah. This is explicitly said as being not, because this doesn't actually make much sense in this case, but I guess might have made more sense originally. Apparently you can set the border or outside set the colors that like it draws in the outside of the main screen area with VGA. So it's the area between the edges, or between the last pixels, and where the actual H sync or V sync is called. In and the display driver on my FPGA board that sort of always filled with black, but or similar. I guess it could be a possibility to actually stick a color there. And in a related thing, or more or less dynamic like ROTT was dynamically modifying the palette in some ways. So so some of this is for. And some of it did work via a linear frame buffer, which it will approximate when needed, or set it into the planar mode. And here's the functions which fake the planar operation. So yeah, it just sort of shifts the target address left by 2 and then mask it off to the size of the screen, and stuff. Uses a plane mask to see which are the 4 locations to store into. On x86, this is not a particularly efficient solution, but for BJX2 it actually works as a conditional store, or predicated store, so that would work out okay. Though even as such, like calling a function like this to write pixels is kind of not super efficient, so the span and column drawing functions are probably going to be rewritten at some point to bypass this logic and probably write into screen memory directly. Or into off-screen memory. As noted. Yeah. That sort of creates a buffer for holding the screen memory and setting up a few variables. All 3 of the pages are set to 0 because because there's not actually triple buffering here. And as noted, yeah, there's not actually a need for having a base address here either, because it's going directly to the screen rather than hardware memory. So yeah. So feature of another recent feature was changed the way LS displays things, and that has colored text because it now has ANSI codes, so slightly closer to a proper console with it can be seen down here. Oh, yeah. sort of prints it out slightly differently if you use an option. Options are basically the same as on Linux, but not quite as many of them for now. As can be noted earlier, I haven't actually filled in any of the sound code for the ROTT port yet, so which is kind of why it was silent. So, X and crash, but I suspect, as noted by the differently colored console, that it is slightly stale. Yeah, working on the exe loader made some minor functional changes, and also some of the system calls and other stuff like that got changed around a little bit, so yeah, that could have been a factor, but I'll see if it works this time. Yeah, that fit seems to have fixed it, probably. So I was testing at slower speeds recently, partly because yeah, partly because I was testing new alpha or new blending logic for the frame buffer. So yeah, for basically for screen color flashes and other stuff like that, these games are more or less using alpha blending, which may or may not be surprising isn't actually the slowest way to do that on this. Because yeah, the original version of Hexen, well, it accomplished things like screen flashes and similar via palette trickery, but since I'd migrated Hexen over to using 16-bit colors, well, the palette trickery no longer works. But so instead of palette trickery, it's using alpha blending trickery. Yeah, so yeah, screen for the screen update, when it does it, it uses a blended version, which basically blends the screen against a constant color. So yeah, uses 464-bit pixels, so or blocks of pixels. So basically, with 4 registers holding pixels and each register holding 4 pixels, it effectively processes 16 pixels at a time. And the algorithm for actually doing the blend is essentially masks it then it shifts it, and then it does conditional, well, in this case, conditional moves. So the first pass, it will just select which of the pixel, or which of the shifted pixels is more, or yeah, closer match to the final color, and it will use that as a starting point. And the next ones it sort of adds, and so basically, yeah, first set of moves, and first set of adds, and then a second set of adds. So basically a 3-bit alpha blend, with each add basically doing 4 pixels at a time. It could actually be a little bit more efficient than this, but this works for now. There's basically the PRWEX encoding, which would allow doing multiple predicated ops at the same time, similar to the non-predicated ops here. But I don't think I've added support for that to my assembler yet, so I have to go and add that, or add that encode, or add support for that particular encoding. So yeah. Yeah, once that we're done, could, replace this logic with something more like this. And I could do pairs of 2. That's one possibility, but since they're not interdependent, I could actually do groups of 3. And yeah, in this case it's using the full power of all 3 execute lanes. So yeah, in this case, we would be able to do all the adds in approximately 3 clock cycles. Here, it will take about 8 cycles for the adds. So yeah. Well, 3 is less than 8, but I have to go and add that compiler feature. So yeah, haven't done it yet. Some operations don't or lack PRWEX encodings, so wouldn't be codable. Like pretty much anything that uses an immediate as its middle value. Most of these encodings are not available as the predicated WEX forms, which is possibly a limitation. Some amount of 2 register some amount of 2 register or actually a immediate and a register forms, those are encodable. So although only in forms where they have a 10-bit immediate value. The forms with 16-bit immediate values and similar are not encodable. is the magic mask. Does a magic mask, and then that allows it to basically shift the pixels right without them, or without the low order bits from one pixel like feeding into the high order bits, or from one component feeding into the high order bits from the next. So yeah. So the mask implements part of the magic for making this actually work. But yeah, since this particular logic is the logic for 16 pixels, it's a little bit wider. The logic for 4 alpha blended pixels would actually be a lot simpler. And also, it doesn't necessarily have to have a separate register for checking the alphas. Like, you could actually pull the alphas from, you could actually pull the alphas from a pixel value this way. Yeah, so a past engine had used a pixel format, like, basically. So yeah, be basically an opaque pixel. Simple case. Put some dashes in there to indicate it's all one value. Yeah. An opaque pixel. And it had gone over to a different scheme for alpha blending pixels, so one to indicate that it's basically a blended pixel as opposed to the normal opaque pixel. But for BJX2, or for blending on BJX2, it would make sense to do it a little bit differently than this. So rather than having the alpha bits all up here and needing to shift everything around to get it into the canonical RGBA or RGB form, or RGB 555 form, can basically do it like this, which would use the low order bit of each component as one of the alpha bits. The advantage of going this way is, as noted, logic for blending, or that assumes blending the non-translucent pixels will still be able to blend the translucent pixels unmodified, mostly unmodified. But other logic will be able to detect this case and then be all like, yeah, I'm gonna use some alpha blending here, using the pixel components as alphas. This won't exactly give that high of graphical fidelity as far as alpha blending goes, but it's probably sufficient. So this would basically be the equivalent of so if this were expanded out to a 32-bit format, a normal opaque pixel, and this case expands out to basically the alphabet's pixel, but as noted, well, depending on how you interpret the alpha, it will be different. So one possibility is, you know, to just pad it out with zeros and interpret it so all 3 bits being 1 set to 1 will not constitute the equivalent of this pixel format. It'll just encode effectively a 7/8 alpha, which would allow a full 8 levels of alpha. And each of the 2 4-bit components would be repeated twice, so expand out RGB as expected, or as usual. The options are either, you know, using 3 high order bits and filling out the rest of zeros, or at least as it would conceptually work, or like, you know, just repeating it 3 times. However, with the blending logic as it works over here, it'll actually behave closer to this case, or yeah, to this case. And so 3 1-bits will always yield a 7/8 blend rather than, well, an 8/8 blend, or 1.0. Actually thinking of it, with this logic, the actual 2 sides won't actually exactly add up to 1 either. They'll add up to slightly less, but that's probably reasonable. A strictly proper blend should probably also do rounding and other stuff like that, but in this case, don't really have the clock cycle budget for that sort of thing. At least from what information I've heard, apparently there's not really any secure or too big of a security risk to people seeing the contents of control panel. So you know, it's always not an ideal thing. Like how much of the engine have I touched? These are object files, so they don't count. Now, everything above this point has been poked out recently. Yeah, all these ones should be still in their original forms, because they don't have modified dates. So it looks like a bunch of headers and roughly 2 of the C source files have avoided being modified by me yet. Actually, I need to check the make file on this one. So, yeah. Which files of escaped modification are apparently not even in the engine. So yeah. Probably explains that. And this one is something. Not sure what it does exactly as of yet, but I know it's not being used. And what is this? Looks like something related to cutscenes or something. it looks like some sort of cutscene player or something. Yeah. Yeah, most everything else in the engine has been modified at least in some minor way in this porting effort. Okay. As noted, I did have to strip out a considerable amount of DOS stuff, which was spread over, pretty much everything. So not much obvious modified there. Yeah, stuff that's not been modified recently is stuff that's, I guess, not needed as much done to it. There's stuff that's more heavily modified, excluding object files. Yeah, some headers that aren't applicable in this case are commented out. io.h technically exists on Windows and also is a common Unix header, but currently that part of the API is not exposed yet, or doesn't exist yet on test kern, so I'm not using it. We'll probably end up adding support for that in the not too distant future, but just don't have it yet. And this change was because I was trying to figure out just what exactly some of the other code was trying to do. It was accessing the names array but passed it into the names array, apparently getting last names via overflowing this array, but of course that wasn't actually working. So I was all like, what the hell? And I realized later what it was trying to do, so yeah. So one of my additions to this piece of logic was the swizzle functions. These ones are, well, relatively straightforward. It's basically an array with hash chains and a hash table. So when the map starts it basically resets the hashes to basically -1 and the array to empty, and then it swizzles the pointers via these functions, which we'll first look it up, and if it's not found, it will add it. This approach is possibly unnecessary because apparently I discovered afterwards that there's an array, at least for entities, that where the entity array index could probably be used instead of like swizzling them into an array, but either way. And stuff. I guess in this case there's two different things associated with an entity. One is the obj type one, which is apparently mostly internal state for the object, and then the stat obj, which is basically represents the state of an object. And well, in terms of like, how it would be presented in terms of rendering. So there's a little bit of a split between like the logic side of the object and its rendering aspects, but yeah. Haven't fully figured out how everything works in this engine, but I just did realize it enough to realize I needed to swizzle these pointers to be able to fit them through integer values, and so I did so. And turns out the swizzling and unswizzling happens relatively rarely, namely when events happen in game and similar, so it's not really performance sensitive, and the hashing is possibly overkill, but yeah, works. Trying to think if there's anything else I should mention. Yeah, so the next logical step after I get everything working in the Windows port of this is that probably I'll go and work on porting it over to BJX2. yeah, kind of wanted to have the Windows port working first because Windows or things are easier to debug on Windows. Whereas after porting it, I have like a lot more stuff to try to second guess as to why it may or may not be working. So yeah, better at least I think to get a known working version on Windows first. But, I will see. I'm not so sure about the performance, given some of the changes I made, but it's a case of we'll have to see. And as noted, yeah, probably replace some stuff with higher performance versions. Yeah. You call it all for now, or call it all for now because I'm running low on ideas for things to mention. Oh, yeah. Not as much this time. Oh, I'll check. Oh yeah. Fancier P loader and added RGB48 mode to the CPU core along the same time, along roughly the same time I moved over to RGB555. Oh yeah, those happened at the same time. Well, maybe. Looks like I did the RGB 555 a little bit further back. No. Oh yeah. Looks like it's about time to end now.